Myself is Abhay Kumar Singh from Atmospheric Research Laboratory, Department of Physics, Institute of Science, Banaras in the University of Varanasi. Today I am going to present a lecture which is topic is Global Positioning System GPS and its application in atmospheric studies. So, this lecture I have divided into two parts. So, the plan of my talk have lecture 1 and lecture 2. In lecture 1 I will discuss about the introduction about the atmosphere and ionosphere. Then we will go deeply about the global positioning system and its components. What are the applications of GPS we will discuss, and GPS basis is how used for atmospheric measurement. So, what are the method of analysis for GPS measurements? We will discuss some results, that is the variation of total electron content at Indian low latitude stations. So, we are living in a region that is a low latitude region. So, I will discuss the result mainly focused for low latitude stations, and also I will try to discuss about the variability of equatorial ionospheric anomaly, that is the EIA during low solar activity period. So, first lecture comprised of this, and second lecture we will discuss about the applications in space weather studies, that is the effect of geometric storm of the ionosphere. What is the effect of solar flares? Solar flares are very active regions. So, how they affect our ionosphere and the total electron content. So, these we will study by using the GPS measurements, and next the application we will study about the total solar eclipse. Sometime solar eclipse is a very fascinating phenomena. So, we will discuss the response of ionosphere during this total solar eclipse, and we will also discuss the seasonal annual variation of GPS water vapor, because water vapor is a very important a component of the climate change, and we will also study the GPS in different crustal motion. Crustal motions are very important. So, we will also study some application of GPS in the crustal motion, atmospheric circulations and water vapor. So, first I will give you information about the interaction with sun and earth, because sun is one of the important controller parameters which is going about near earth environment. Our near earth environment is highly affected by the sun. So, sun is affecting the sending the solar wind, that is the charged particles, ions, electrons coming from a large velocity. So, these when it comes, they compresses the earth magnetic field. So, earth magnetic field is compresses in the day side, and the night side it elongated several thousand kilometers. So, it forms a cavity which is known as magnetosphere, and this magnetosphere is the cavity by which we are not affected by these high energy particle coming from sun. So, it makes a cavity and our life becomes simple, and the second is the ionosphere. So, ionosphere atmosphere is the upper gaseous envelope in which the ions and electrons. So, if we talk about the atmospheric layer, we will say that there is a lower layer which is known as troposphere, stratosphere, mesosphere and thermosphere. It is very simply known by the earth scientist. I will focus the ionosphere. Ionosphere is a conducting layer where ions and electrons are formed. So, there are also different layers in ionosphere which is known as D layer. D is the lowest layer of the ionosphere, then comes the E layer, then F1 is divided into F1 and F2. It has distribution day side and night side. Night side they merge. So, F1, F2 merge to form F region, and D layer disappears. So, this is the earth ionosphere which is a conducting envelope which makes the radio wave propagation very important. So, ionosphere is very important when we talk about the radio wave propagations. Then I come to the GPS, because today lecture is GPS. So, how GPS is important? GPS is basically started by the United States space based radio navigation systems. It is used to design for navigation and military purpose. Nowadays, we are using the civilian usage also, and worldwide it is free available to all body. It is all weather system. So, for any one which a GPS receiver can study the location of a point, that is the latitude, longitude and height, and it also provides the time, very accurate time. So, it is a all weather day and night anywhere in the world system. So, it is a very reliable system and working from 1996 to till date, and it is providing lots of information. So, it has a three important segments. We call it GPS segments. One is known as a space segment, another is known as control segment, and third is known as user segment. The space segment combines of the satellites, different constellation of satellites, and the control system are the control stations. There are various control stations at different places in the globe, and the users is by anybody who has GPS receiver, either it is navigation, aeroplane or ships or anybody which has a GPS receiver. So, a space segment consists of 24 satellites in different orbits. There are 6 orbital planes in which 4 satellites in each orbit. So, there are total 24. So, these are at the height of 20,200 kilometer from the surface of the earth. So, they are inclined and 55 degree, and they are continuously sending L band signal, that is the two dual frequency, that is known as L1 and L2. L1 is around 1.5 gigahertz, L2 is around 1.2 gigahertz signal. So, any place, these are designed so beautifully, any place in the globe is such that we are able to find at least 6 to 12 satellites, and if you wanted to know the position of a place, we need minimum 4 satellites. How we can find, and the control segment are the various control stations whole over the globe. So, it is also distributed that anywhere you will find at least one station above the space. So, they are beautifully distributed in whole over the, and the control station is in USA, Colorado. A user segment, as I have said, any GPS receiver, anybody nowadays everywhere GPS receiver is in GPS car, GPS receiver in mobile. So, anybody who has a GPS receiver is the user. So, GPS signals, what are the important signals? There are, I have talked about, there are 2 signals, that is 2 basic signals which is known as L1 and L2, but basically it has 5 signals: L1 carrier, C by A code, Navstar data, P code and L2 receiver. But these all mixed and makes 2 important signal L1 and L2 which we are using. So, finding the position, how you can find a position on the earth? Anywhere we need a distance. The distance is called by time of total TOA into speed of light. So, where is the location and what is the speed of light, we can calculate. So, one satellite is not sufficient, we need at least 3 satellites, and the triangulation method is used to find the later. Suppose we have one satellite, so it will give information it is at the x1 distance. So, then suppose they have 2 satellites, so it will give location as x2. So, x1 and x2 cut at 2 points. So, 2 satellites will give 2 locations. So, it is difficult. So, we need a third. So, when third will come, so these all 3 x1 and x2 and x3 cuts the 3 circles at a single point. So, now we are able to find a simple location, that is the x, y and z coordinates, and it is converted to latitude, longitude and the different height. So, here we see minimum 4 satellite is required to find the location of a place. So, GPS, this is designed such that anywhere we are always find more than 4. Generally, we get 6 to 12 satellites at a point. So, we are able to find. So, these are the equations. So, different equations are used to calculate the location, because it gives the range, pseudo range. So, we can find by solving the equations, we are able to find the user location, because it gives in x1, x2, x3. So, this x1, x2, x3, y1, y2, y3, z1, z2, z3 gives a position, that is the latitude, longitude and height. So, we are able to find exact location of the station at this. So, these locations are converted latitude and longitude. So, on height is also very. So, we are also able to get the latitude, longitude, height and time also, as 4 important parameters can be calculated by using, and these all calculations are done by the server in the ground station. So, ground stations get the information for 4 satellites, and in microsecond they solve to find the location. That is why it is very, very important tool. So, there are tremendous applications of GPS. Nowadays, you will observe that each step of the life we have a application of GPS. Since it is designed for military purposes, so I will talk about the first, the military applications. The basic need of the armed forces to find the good navigation system, to find the accurate all weather system, easy to use and portable. So, these is achieved by the GPS. So, in military application, we are able to navigate, we are able to track, we are able to guide the bomb and missiles. So, bomb and missiles have to guide a precise location. So, GPS will provide them the precise location. we have to do the rescue operations. Rescue operation also we have to need the specific locations. So, GPS provide the specific locations that will be used to rescue the operation, and for providing the management and mapping military applications are tremendous. In aviation, all aviations the GPS is used. So, they use in India we are using the Gagan program. India has a Gagan program, and GNSS, Global Navigation Satellite System is there. So, Global Navigation Satellite System uses the VAS system, Gagan system. So, each country has its own program, and by which the all Airport Authority of India they use a GPS in their station. So, Varanasi has also GPS, Delhi has GPS, all navigation stations has a GPS, and they have designed a grid frame. So, each 1 degree, one GPS receiver is kept in India. So, whole over the India more than 22 GPS are placed to find the location of the aviation, how to fly, what is the landing, what is the takeoff, and where to go, what is the air traffic control. So, all is controlled by the GPS in the aviation sector. In a spacecraft the GPS is very important, because we have to launch a space shuttle. So, where it has to go, what is their ground launch, what is their orbit launch, what is their re-entry in the atmosphere, and how they can land, all requires precise calculation. So, GPS helps here for a spacecraft guidance. In maritime, initially the maritime people use simple compass and they go different places. So, in maritime it is very busy, because we have only water and water everywhere. So, marine peoples will use GPS, and they will know the locations, the different travels in different weather conditions, and it helps a lot. In land, you are very aware, in all vehicles are equipped with GPS nowadays, and we are able to locate. Just you give the locations and it will guide you where to go, okay? Because most of the roads of the world as well in India are tracked by the GPS. So, they are mapped by the GPS. So, we are able to go anywhere in the land, cellular force data functions. So, everywhere it is used for mapping. In GIS, as you are aware that Geographical Information System is a very important tool nowadays for the research in earth sciences. In whole about the earth sciences, in mapping, in agriculture, in remote sensing, the GIS is using, and the backbone of GIS is GPS. So, GIS utilizes the mapping, automated airborne mapping, and remote sensing, photogrammetry. These all requires the software of GIS and GPS. So, GPS helps to find the real time different global navigation system applications, and it will be used to provide the data and monitor the different applications. So, in agriculture also we use GPS and we map the GIS, we are providing this accurate data by the GPS. So, when we are using GPS, we experience different types of errors. So, we have to know about what are the GPS error sources. These error sources may be of system and may be of the medium. So, system satellite clock error. So, suppose that there is a atomic clock in GPS, the atomic clock you use which is very precise, but sometime there is a small error in the clock. So, this small error also affects the exact calculation of the time, and that is very important, but there is a error. In inference error, there is a inference error. This error arises due to the small error of the transmitted satellite. So, there is a location and computation of the position. Sometimes there is a error by the computation of the position, that is also provided, and sometimes multipath error. Multipath happens, suppose that satellite signals are coming and there are skyscrapers. So, when you are using the GPS in the city and multiple buildings are there, so signals are reflected and received also. So, where a person is using satellite and they are receiving 2 signals, and he found that there are 4 signals are coming. So, 2 signals are reflected from the buildings. So, his path is longer. So, that will produce a multipath error, and there are also noise in the receiver. Nowadays lots of receiver has been launched. Some receiver are very good, they have a very accurate signal, but some receivers are noisy signal. So, that also produces a error in the noise. And most important error which is important for today talk is the atmospheric error. When GPS signal passes from 22,000 for atmosphere to 2200 to the ground, they have to pass through the envelope of the atmosphere. So, when they are passing, there is a ionosphere and there is a troposphere, which I have already given information. Ionosphere, when they passes through the ionosphere, which is a layer from 60 kilometer to 1000 kilometer conducting atmosphere. So, when the signal passes through the ionosphere, they are dispersed and they produce a delay in the signal, which is known as ionospheric delay. So, we are not able to find exact timing, there is a delay. Similarly, the troposphere, they are water vapor. So, these water vapor are also conductive, they forms a dipole. So, they are known as tropospheric delay. So, ionospheric delay, tropospheric delay, these two types of errors are very important, but it is very good also for the research purpose. By these errors, we calculate the error and we convert to find the ionospheric electron content and the water vapor content, which I will discuss. So, first ionospheric error. Ionospheric delay is due to the frequency, is frequency dependent. So, ionospheric delay is GPS signal is proportional to total electron content of the ionosphere. The total electron content is the number of electron from source to the receiver. So, when the signal passes through source to receiver, it has to go through the ionosphere and most of the electron content is ionosphere. It has a area of 1 meter. So, 1 meter column will provide a total electron content, which is about 10 to the power 16 electrons per meter cube. So, in cylindrical column, the total electron is known as a total electron content, which is defined as total number of electrons in column of 1 meter square cross section area along the ray path from the satellite to the receiver. So, this ionospheric delay is important because this ionosphere varies. So, it varies with different frequency, it is a frequency dependent. So, when frequency of signal L1, suppose that L1 frequency is coming, so it passes through, and if the total electron content has changed, it can be changed by space weather, it can be changed by solar flare, it can be changed by any geomagnetic phenomena. So, when it changes, it produces additional delay. This is known as ionospheric delay, and this delay is up to several total electron content it can go. So, why we need to study total electron content? Why total electron content is important? Because total electron content varies day to day, varies day to night, varies seasonal distribution, and it also varies with different space weather phenomena, and it affects the geomagnetic storm also. So, when we are using the navigation, aviation and communications, they will give a error of few meters, and few meter error is also a very big problem for navigation, aviation especially. So, this is important to study. So, this can be calculated by the different method. One method is the code pseudo range measurement method, and another method is the carrier phase measurement method. So, by using the two methods, we are able to find the total electron content of any point of the ionosphere. So, here I will presenting you the GPS-T variation at Varanasi. Varanasi is a station which is a low latitude. It is also situated at the Equatorial Anomaly region, crest of the EIA crest. So, we have to know the total electron content, and here you see the total electron contents of this different satellite signal is coming. So, which is averaged for find a daily variation. So, 24-hour the maximum variation is found in the noon time around 12 o'clock or 6 UT time. UT is the universal time. So, local time, that is called IST, around 12 it is a maximum, and then in night and the morning the total electron content decreases, because the electron content has started due to the photo ionization. The radiation coming from sun ionize the ionosphere. So, in the noon time the total electron content is maximum. Second type of delay which I have talked about, the tropospheric delay. Tropospheric delay generally is known as wet delay. This is the zenith tropospheric delay, which comes due to the water vapor. There is also contribution of O2 and N2, this is known as dry component. So, we can subtract the dry component and we find the wet delay, and this wet delay is important to compute the total water vapor content in the atmosphere, which is one of the important global warming parameter. So, water vapor is related with the total total water in the column. So, when we compress the total water in the column from source to ground, it becomes a liquid, and the thickness of the liquid is known as water vapor content, which is also known as precipitable water vapor. It contains a column of unit cross section, and it expresses in terms of the height, that is the in millimeter or centimeter. Total water vapor, that is total water vapor converted to water. And at Varanasi, we are using 2 GPS in physics department, atmospheric research laboratory. We have 2 receiver, one is the GPS receiver, which is known as Trimble 5700, another is the GSB 404. So, it is installed in 2007, and from 2007 to till date it is working successfully, and we have a bunch of data for the study of ionospheric as well as the atmospheric study. This gives the data in the RANX format. This RANX format is the compatible for any software system. So, RANX format provides 3 type of data. One is the observational file, second is the navigational file, third is the meteorological file. So, these all files provides the computation. The second system which we had talked about, the GSB 404, it is a Navital system, it is installed in 2008. So, both are running successfully in Department of Physics. So, it will provide you the path of the satellites. So, if you see that each locations there are different satellites. So, first it will provide the path of the satellites. What are the different path over the sky? So, it will give the sky view, and you are able to find the total sky view and provide the path of the satellites from where it is located from our Varanasi overhead. So, we get the ionospheric data using also models. So, ionospheric reference model is a model which provides the TEC. By using the ionospheric model and using the GPS model, GPS experiment, we can validate our data also, and we will get the corrections in the model. So, GPS is used to correct, to validate the model data. So, in Varanasi we have used this is the plot of the 3 years data for 2007, 2008 and 2009, and we have found the distribution. You will see the distribution has a seasonal distribution as well as the diurnal variation. The maximum is around 12 or 8 UT, that is 12 IST. So, 12 IST the density is maximum, and it has seasonal variation also. The seasonal variation is equinox month. Equinox months, it has April and May maximum value, and in September, October there is a maximum value. So, this is validated by model data also. So, sometimes the model is not able to give the perfect data. Here also you say the different model data. So, we compared the model data in different models available. One model is the RIA model, International Reference Ionospheric Model, and Varanasi data as well as the Bangalore data as well as the Hyderabad data. So, 3 data we have compared, and we are able to find the seasonal variation. So, these seasonal variation is compared, and this is published in a atmospheric space science publications, and it will very good provide that our GPS can be used to modify the data of the model. So, model parameter can be improved, validated and further used for better uses. So, what we say that TEC, total electron content, is found maximum during the equinox months in Varanasi. It has a seasonal variation, and seasonal variation is maximum in equinox and minimum in summer. As we move with the EIA, EIA is the Equatorial Ionization Anomaly, and if you move, there is a maximum value in diurnal peak is found, and the result presents so a good agreement between the GPS, the ground observation, as well as the RIA model, and our data also validated the model, and it is used to find the spatial distribution as well as the improvement of the model. So, equatorial ionization anomaly I have talked about. So, equatorial ionization anomaly is found that at equator the value is not maximum. By theory, the maximum value should be at equator, but due to the anomaly is rises up and it goes to equatorial regions, that is the plus minus 30 degree. So, plus minus 30 degree maximum is, and Varanasi is around 15 degree. So, it is near to the equatorial anomaly, and if you see the equatorial anomaly, this you will see that the TEC rises above and it goes along the geometric field lines due to E cross B field, and it falls to the two crest from 15 degree to 20 degree. So, at 15 degree 20 degree geomagnetic latitude, the value of electron density is maximum. So, this is the EI. You will see this simulation can exactly show that it is going up and going down, and there is two maxima which is known as ionization crest region. So, this is also so, this is the satellite and different model value. So, different model values show that there is a EIA crest region. So, two latitude plus minus 30 degree has a two maxima. So, TC has a total electron current है maxima. This is a formation of EIA, Equatorial Ionization Anomaly region. Both the plus minus 20 degree, the electron density will found maximum. And day to day variation of this EIA region we have sent, and we found it has a simple variation of semi-annular variation. So, whole 1 year data we have analyzed, and we found there are two maxima, one maxima in equinox month and there are two minima in winter and summer. Similarly, we have tried to find the effect of solar and geometric activity, how the solar parameters and geometric parameter affects the total electron current. So, for each we have plotted the sunspot number SSN, sunspot number and total electron content at Varanasi, and we have taken the solar flux F 10.7 data and Kp index and DST index. The Kp index is the present index and DST is disturbed start time index. So, disturbed start time index is used to find the correlation, and we found that there is a good correlation with solar activity, but for geometric activity the correlation is not so fine. So, we have also calculated with the statistical mean location, and it has a Gaussian distribution, and this Gaussian distribution we give them a full width half maximum, and we can found that this is a good correlation. So, what is the conclusion of the EI study? The value of EIA crest in TEC shows seasonal variation, which I have shown you. It has a maximum in equinox month. The variation in EIA crest in TEC shows semi-annular. There is a 6 monthly distribution, and seasonal variation is influenced by the Kp index and DST index. So, this geometric indices effects is there, and a statistical analysis also shows that there is a geographical latitude 20 degree and it has a maximum. So, this is the end of my first talk. Thank you.